Welcome back to physics, and today we're going to talk about projectile motion.
Projectile motion.
So, we've already talked about horizontal projectiles. This is a slightly different type of projectile where we are launching it at an angle. So we do have a practice problem here that we're going to go through. You are going to be filling out a chart again, just like you did with all of your other projectile questions. So be prepared to do that and write out all of our givens.
First thing you should do, though, is always the first thing for one of these problems is going to be draw a picture, or dab. So the first thing you should do is draw yourself a picture of a guy throwing a football, or a woman throwing a football. Doesn't really matter, but someone throwing a football. Now, it says a football is thrown at 20 meters per second at an angle of 25 degrees to the ground. So you're going to draw yourself a little person, a ball, arrow up off of the ground. So now we can label our angle from the horizontal to be 25 degrees. Now, it says 20 meters per second. Where would I write that 20 meters per second? You're going to write it right on top of that vector right there because that's the angle you threw it and the velocity you threw it at. So, 20 meters per second. You can draw in the path of the ball. You should know that it should follow a parabolic or a parabola path from one side to the other side. Now we're going to label our x distance as a question mark because that's what we're trying to find. Let's assume that somebody catches this ball over here at the same exact height that it was thrown from. The reason we want to do that is because it doesn't say anything in here about how high the person is at catching it, and it doesn't say that it hits the ground, and we don't want to have to worry about how high it was thrown from, so that way we can say that this ball was thrown from this height and returns to this height. Technically, that could also be the ground. You picture a soccer ball being kicked off the ground and then returning to the ground, it would be the same problem. We're just not worried about this height here. Step 2. You're going to draw your t-chart, x and y axes. Now, you can fill it in the same way each time, as I know Ms. Becker does, and my students so nicely pointed out that they like her t-charts better than mine. Mine are random, hers are done the same way every single time. I don't really care if you do it that way. Have fun. So, VI in the x. We don't know yet. VI in the F.
VF in the X.
Sorry, VF in the X. We also don't know yet. Acceleration in the X, we do know. We know that anytime we throw an object in the X direction, there is nothing to slow it down and nothing to speed it up once it has left that person's hand. So we also neglect air resistance, so acceleration should be 0. What about in the Y direction? This ball is let go of, and it goes up and comes back down because it has an acceleration in the Y direction. Be very careful here. You should actually list it as a negative 9.81 meters per second. Now, why do we want to make sure it's negative?
The object is going up and coming back down. So we're talking about things happening in 2 different directions. Since we're talking about 2 different directions, one of them has to be positive, the other one has to be negative. If we didn't put that negative, there are some times when solving through equations, things are not going to work out. Things are going to get messed up, you're going to get some wrong answers. So since we're going up here, so we have some initial positive velocity, and then it comes back down in the opposite direction, we have to consider that.
Alright, the rest of them, distance we don't know, time we don't know. But the question is going to be, how come I didn't take this 20 meters per second and write it in here or here? Well, the answer is because it's not true. We did not throw it in 20 meters per second in the x direction. We did not throw it at 20 meters per second in the y direction. We threw it somewhere in between. So what you have to do is resolve that vector, which means break it down into its x and y components. So let's erase the problem and let's actually start working on that. Take out your second best friend, which is your reference table, and look for the equation that tells you how to break down a vector.
You should find 2 equations in the back of your reference table. I forget which one comes first. But you have ax equals and ay equals. That a stands for any vector. Could be velocity, could be displacement, force, acceleration, any vector at all. And for AX, it says that it equals A cos theta, and AY equals A sine theta.
We have already gone over where these equations come from in class, so there's no reason to do it again, but the short answer is it comes from trig. So if you did your trig, you would always get AX is equal to A cosine theta, and AY is always equal to A sine theta. Remember, as Ms. Becker said, A means any vector. So what that means is any vector's x component is equal to that vector, the 20, times cosine theta. So now we just plug in. It's going to be 20 cosine 25 degrees. And 20 sine 25 degrees. So 20 cosine 25, and you get 18.12, and 20 sine 25, 8.45.
Now notice how when I was plugging in, I wrote out my degree symbol. That is a unit. Don't forget it. If you forget it, points off. Okay, that counts as plugging in with a unit.
Now, we can take this number here, AX, 18.12, and write it into your t-chart of 18.12 meters per second in the x direction. Remember, there is also no acceleration in the x direction, so your x final should be the same as your x initial, 18.12. We also now have AY, which is our velocity in the y direction, which is 8.45. Now, VF and the y, you can write in a couple of things. The one thing I like to talk about all the time is that if you throw something straight up, what's its final velocity at the top of the motion? Well, at the top of the motion, its final velocity would be 0 in the y direction. Otherwise, it's not the top. The ball has to go up, stop, then come back down. So if you want to make the distinction and say at the top is 0 meters per second. So at top, 0 meters per second. But what would it be when the person catches it? It turns out that because the acceleration is a constant, the y velocities are symmetrical. So as long as we catch this ball at the same exact height we threw it from, its final velocity would be the same exact magnitude, but in the opposite direction. Negative 8.45 meters per second. You can check the math and figure it out for yourself, but please understand why motion is symmetrical. Okay, so now we want to find the distance in the x direction. But the only thing we're missing right now is time. So how do we find the time?
So again, if we're trying to figure out our time, we said when we were looking at horizontal projectiles, most of the time you're going to be using the y values to figure out your time, and somehow moving it over to the x column. So we're going to be doing the same exact thing here, because if we look at our x column, we have two velocities that are equal and an acceleration of 0. We can't really solve for anything else. We have that one equation that we talked about that we can use there, and we don't have enough information. So if we go over to the y side of our column, we have VI, we have VF, and we have our acceleration. We're looking for time. You should recognize that we can go to the equation VF equals VI plus AT. Now, as we were saying before with talking about your different velocities, it's up to you which velocity final you choose to use. Personally, I like working with the number 0. It's nice and easy to work with. But you could also use the negative 8.45, and we'll talk about what that does to our time once we solve it.
Now be careful. If you choose to use the real final velocity, you must put it in as negative. That's why we like to use the zeros, because there's no negative 0. So what Ms. Becker's going to do is she's going to say, well, 0 is equal to, I'm reading your parentheses as a 1, but it's parentheses 8.45. So she's going to fill in her initial velocity of 8.45 meters per second plus acceleration times time, solve for the time. Now, you cannot simply just subtract that whole thing over to the other side algebra problems here, what you're going to do is you're going to subtract the 8.45 over, then divide by 9.81. So notice when you subtract the 8.45 over, it becomes negative 8.45 divided by a negative number, which gives you the positive number. So 8.45 divided by 9.81. I'm doing too much talking. 0.86 seconds.
So now let's talk about what that time is actually measuring. We plugged in a final velocity of 0, which we said happens at the top. So we only really found the time to this halfway mark. And it's important to note, as we were saying before, it is symmetrical. So if we figured out how long it takes to get halfway, all we have to do to figure out the other half is double it. So when I go to write into my chart over here, I can write in, and I'm going to kind of split up my y time. Because my y is the only one that I might want to use my half, I might want to use my whole. So I'm going to write in that I have 0.86 seconds, and note over here, that's my half time. But I also have a whole time of 1.72.
Now, where the I'm not in the shot right now, but
Sorry.
I know where did 1.72 come from? Well, you take that 0.86 and double it, because remember, it was only half the time to the top and another half the time to the bottom. So 0.86 times 2 gives you 1.72.
So that's going to figure out the entire time that this ball is in the air. And when we're talking about our x, we're talking about the distance from where it started all the way over to where it ended. So we care about the whole time when we're looking at x. So
Yeah.
I'm going to write 1.72 over here for my x time.
If you had plugged in the negative 8.45 into here for your final velocity, would you have to double the time? And the answer is no. Because if you went in started with the initial velocity and the final velocity of negative 8.45, you've included the whole motion. So you can avoid multiplying by 2 if you use the 8.45 here, but remember, it must be put in as negative.
Alright, so now we want to finish this out because the question was really asking us, how far away does your friend have to stand to actually catch this ball? So, we are trying to solve for the distance in that x direction.
Remember, this is a distance in the x, not the y. We solve for time using y information, and all the numbers that Miss Becker plugged in were from the y column. So now, if we're trying to find a distance in the x direction, all the numbers that we can plug in must come from the x column. You cannot pick and choose which ones you want. So, everything before was all y, this stuff is going to be all x. There's only one equation you can use in the x direction because the acceleration is 0. That equation is v is equal to d over t. Now, I know a lot of people get confused because it says phi bar, and they say, well, I don't have the average. Yes, you do. If your velocity is a constant, that average is that constant. All right, so we have 18.12. Then we have a distance, which we're looking for, and a time, so we're going to multiply 18.162.
Make sure you're plugging in your full time here, because like we said, we're talking about x. In x, we always talk about our full time.
So 18.12 times 1.72 gives you 31.16 meters. So how far away does this person have to stand? 31.16 meters. If you try this in real life, would he really have to stand 31.16? No, he'd have to be a little bit closer. The reason why, in real life, there would be wind resistance. But in physics life, there is no wind resistance.
Now the other thing that we could have to solve for, which we will leave to you guys to try, is solve for how high the ball goes. So we want to figure out how high the ball goes. So that would be this distance here in the y direction. And I want you to think about which time you need to use in order to do that.
Also, the other hint we will give, if you're trying to find a distance in the y, should you be using x information or y information?
So try that. You're going to enter in your answer for us to see what you got. And any other questions that you have, you're also going to enter in. We will be having a test on all of projectile motion, horizontal and at an angle, sometime next week. So if you're having any problems with it now, please come to Extra Help.
And as always, have a great night.